Good morning, everyone. So sorry we have to make this video. So like I told you, beginning of class, my son is sick this morning, and I just don't know how that would interfere trying to teach live. So I thought it'd be better if I just went ahead and made a quick video to help you fill out the slides today. And then I'll be available this afternoon for tutoring still on the Canvas. If you have any questions, you can also email me. You're also going to hear a really annoying beeping because as soon as my husband left for work this morning, the smoke alarm started making this noise and I'm not touching it. So I apologize for that too in this video. So a couple things I want to show you. Make sure, so the new assignment sheet was linked. You did Friday's assignment. Hopefully already by this morning on long division. We'll be using long division in one of our problems today. So today's Monday. The original assignment did not change except to fill in slides 2 through 4 from the Unit 2 Digital Interactive Notebook. You're watching the Edpuzzle that I'm making right now instead of watching me teach live in class. So make sure as I'm filling the slides out in the video today that you fill in slides 2 through 4. So you've gone on Canvas, opened up the Unit 2 Digital Interactive Notebook, and you're filling out these slides. Okay, it's really 2 and 4. Slide 3 is just some notes. Okay, all right, let's get started. So on slide 2, you see we are talking about rationals. The rational graph is hopefully one you've seen before. You saw it in Math 2. You should have seen it in Math 3 as well, especially if you had, well, actually, I think both semesters, no matter when you had Math 3 honors, you saw the rational unit. So here's the rational graph. All right, I'm going to move rooms. I'm going to pause. All right, so here's the rational parent graph. You see it right here on the right-hand side of slide 2. The rational parent graph equation is f of x equals 1 divided by x. That's also written here at the bottom of slide 2 on the right. And we're going to fill out a few values of the table together. So what makes something rational is having x in the denominator. Okay, so we're thinking fractions in this whole unit and having x in the denominator. That's what makes it rational. So if we plug in some values of x, we'll just start with plugging in. We'll just do a -3 down to +3. Making a normal little table. Oh, -3 to +3 is not going to fit. Let's do -2 to +2. All right, so if we think about doing 1 divided by -2, I'll kind of go here just to help you visualize. All we're doing is plugging in to this equation, right? We're plugging in x values. So if we plug in -2, then we're saying, what is 1 divided by -2? All right, it doesn't matter where the negative is. The answer is just -1/2. And that just makes the fraction have a value of -1/2. So when I plug in -1, 1 divided by -1 is just the number -1. You cannot divide by 0. Right? We will learn tomorrow and Wednesday what that means on the graph if you're trying to divide by 0. But for right now, we just know 0 is not in the domain. You get an error. So 0, not in the domain, you can just put a line, you can write error, you can write NA. This is, again, what we're focusing on Tuesday and Wednesday is what's happening in the graph when you're dividing by 0. There's 2 different things that can happen. All right, and then if we plug in +1, we just get +1 back. And if we plug in +2, we get +1/2 back. All right, so let's go back and fill in those values on the table. And you can do fractions or decimals here. I'm going to do a fraction because it's probably easier to type, but you can do I'm sorry, I'm gonna do a decimal because it's easier to type right now, but you could do a fraction if you'd rather. Again, you can do error if it fits better. You can put in A. It's just not in the domain. And you see on the graph, it's not there. A 0, there's nothing that's happening as far as the graph is concerned. So what happens on this graph? Obviously, I've already got a picture of it there. We know that you can't divide by 0, which actually makes this graph have a vertical asymptote. So it's an asymptote, a line that we can never cross, that the graph approaches from both sides. If you look at all the x values from 0 to 1, you see that, so we did negative, or we did positive 1, but we didn't do anything in between it. Let's actually plug in something between 0 and 1 so that you can see why we're getting such high numbers. So what happens if we were to go back and plug in, let's say, let's let x be 1/2. If we do 1 over 1/2, remember with fractions, if you're dividing fractions, then that's basically keep. Well, first let's write it this way. 1 over 1/2 is the same thing as 1 divided by 1/2. So if I wanted to plug in and see what's happening, I have to change this to 1 times 2 over 1. That's how you divide fractions. I think a lot of you learned it as like keep, change, flip. It's just how you divide fractions. So we actually get the number 2 back. Let's plug in some more fractions. If I were to plug in 1/3, right? So 1 over 1/3. 1 over 1/3, keep, change, flip, I get 3 back. Okay, let's go even smaller. Let's go even closer to 0. Let's do 1/4. 1 divided by 1/4 is keep, change, flip. We get 4 back. So the closer we were to 0 in that set of numbers between 0 and 1, the larger the y value is. And that's why on the graph, we see that it's actually decreasing, 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 decreasing down to the points that we found. We found 1, 1 in the table. We found 2 would be at about a half, right? We've got that one. And if we kept going, if we plugged in 3, 4, 5, we would get 1/3, 1/4. So we're getting smaller and smaller numbers. Same thing happens on the left-hand side. We're just in the negatives, because if you divide by a negative number, then you're going to get a negative number back as a y value. And so the same thing's happening on this side. So as far as the domain goes on this, the only number that's not in the domain is 0. 0 is the only number that I can't plug in for x. So it looks like this: negative infinity to 0, but you are not going to use a bracket. You're going to use a parenthesis because it cannot be 0. You're saying all the numbers from negative infinity to 0 work, but not 0. And then union 0 to positive infinity. So the way that we're writing this, it excludes, the only number it excludes is 0. And we're showing that by using the parentheses on 0, not including it. 0 is the only number not in the domain. Okay. The same thing's actually true for the range. Now, we talked about that as we're plugging numbers in, like 2, 3, 4, 5, 6, 7, we're getting fractions back. We're getting, if I plug 7 in, I'm going to get 1/7. So if we thought about extending that, if I plug 100 in for x, I'm going to get 1 over 100. I'm going to be getting such small numbers back, but I'm never going to get 0 back. You can't divide by something and get 0 back. So 0 is also excluded from the range. There's no way to get 0 back in as the y value. And it's the only number excluded from the range. And the reason for that, what happens on the graph, we talked about the reason for that mathematically. What happens on the graph are we have these asymptotes. So hopefully you've heard that word, but just as a refresher, an asymptote, anytime you see this, we'll see this in the next couple units. An asymptote is a line, it's an imaginary line. The graph approaches, but never crosses or touches. So for us, we have a vertical and we have a horizontal. You can have other types we will learn about actually this week, but the most common ones, the ones you have learned about, are vertical lines and horizontal lines that the graph would never cross. You've probably done more with horizontal because exponential graphs have horizontal asymptotes, and exponential functions are something we've seen before. Okay. We're going to have tons of different types of asymptotes in this unit, though. So a horizontal line is a line that starts off y equals. And we have a horizontal asymptote at y equals 0, which is basically the x-axis. We're never crossing the x-axis. I want you to write both because it is so common that people get these confused. They see horizontal asymptote and they answer with an x equals line, and that is incorrect. I will mark that incorrect. So you need to make sure if it's a horizontal line, it's y equals, and then it's whatever the y value is that you're not crossing. It will not always be 0 later this week. Again, we're doing the parent graph right now, which is why it's 0. All right, vertical asymptotes always start off x equals, and then it's the x value that's not in the domain, the x value that's the problem. For us, that was 0. So x equals 0, which again, this one is the y-axis. It is not always, this is the parent graph, remember. So we will see examples later this week that have been shifted and have different vertical asymptotes, different horizontal. But for this graph, for the parent graph, it's the x and y axis. All right. And then this graph is actually, it's decreasing forever, but it has two pieces of a graph that never touch. So the part on the left in the negatives in the third quadrant, it is decreasing, 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 decreasing. It's going to decrease forever. Remember, we answer that increasing, decreasing, we answer in x values. So we would say it decreases from negative infinity to 0. But there's a second portion of the graph, and it's also decreasing. This portion of the graph is also decreasing. So we have to say that there's two answers to decreasing. You can just write the word and in between it. It also decreases from 0 to positive infinity. This graph decreases forever. Rationals can increase, but it would mean there was a reflection. So the parent graph is always decreasing and never increasing. Okay. Slide 3 is just there for notes for you. This is just reminding you we learned transformations last unit. And then where we were used to with things like quadratic, that's what we really stayed with last unit. We were used to everything happening in parentheses. You need to kind of switch your head now to thinking everything horizontal happens where x is. So in quadratics, x was being squared. It was in parentheses. But in rationals, x is in the denominator. So anything horizontal is happening in the denominator. Shifts, stretches, shrinks, happening in the denominator. Vertical stretches, that's going to be a number that's found in the numerator. It's being multiplied by the whole fraction. And vertical shifts are added or subtracted. So I gave you some basic examples that you can have in your notes to look back at. And we're just going to jump to slide 4 and work these out now, okay? So let me get them on my screen. So we are going to, this is where we're going today. We're just going to be looking at finding transformations from the parent graph based off of what we've learned about transformations before. All right, the first couple are a little easier. So we'll start there. So remember, we are finding transformations from the parent graph, and the parent graph equation is f of x equals 1 over x. So anything in the denominator is horizontal. So if we look at number 1, or the first problem out there on slide 4, instead of x in the denominator, we have x minus 4. So that is going to show us that this graph has moved right 4 units. Okay. The -2, the -2, the subtract 2, it is not in the fraction. It is being subtracted from the fraction. So that is going to be a vertical shift. It's telling me that it moved down 2. Okay. I want to rewrite the second problem. We typically would see, since that 3 is not being multiplied, this 3 is being added or subtracted to the fraction, we would actually see this written like this, or we would think of it this way, sorry. The -3 over x minus 1, and then because this is a +3, we would see a +3 at the end. But that's how we need to think of it. So 2 of these we already should know. We should know that the -1 in the denominator is moving right 1 because it's affecting just the x in the denominator, and that the +3 on the outside, that we're adding 3 at the end, that moves up 3. The 3 that's in the numerator, this is what this, if I break this apart, this is what's actually happening. -3 times a fraction. Remember, when you multiply fractions, you multiply just the numerators and then you multiply just the denominators. So if there's a number in your numerator, you could think of it broken apart like this and see that, hey, that number's just a vertical stretch by 3, and be multiplied by 3. And then the negative, if there's a negative out front, that's an x-axis reflection. Okay. So the negative's a reflection, and the 3, or the numerator, that's a vertical stretch. All right, let's look at the next one. It is not easy to tell transformations from this form because there is an x on the top. We need there to be either a 1 or a different constant on top. So this is why we learned or reviewed how to do division. You need to first do a long division problem. And I say long division because your numerator could be, it doesn't have to just be x minus 1. Like the next one, we would only be able to do long division. So I say just do a quick long division problem, and then we can find transformations. So the number, or not the number, the polynomial on top will go inside, it's your dividend, and the denominator, the polynomial on bottom, that's your divisor. Fractions are just division, so you're just going to do a division problem. All right, quick problem because you reviewed division Friday. 2x divided by x is 2. 2 times x is 2x. 2 times -1 is -2. And then subtract. 2x minus 2x goes away. 3 subtract -2 is +5. And then remember, you write your remainder over your divisor. So our answer, what we got when we divided this, we actually got 5 over x minus 1 plus 2. And this is much easier to tell my transformations from. So you want to do that quick division and then find your transformations. This graph moved right 1. It moved up 2. And it had a vertical stretch by 5. You could not tell all of those things from this form, so you need to do the division. You would only have been able to tell me it moved right 1. Okay. All right, one more. So same thing, we're going to do division. I recommend flipping your denominator so that the x comes first before you do your division. Because remember, we have to compare the x's when we're dividing. All right, 3x divided by -x is -3. Multiply and subtract. 1 minus 3 is -2. All right, this one's going to be fun to talk about. So I'm going to write the answer down. Basically, we got back -2 over -x minus, oops, no parentheses, over -x minus 1, and then we have a -3 at the end. So we have a couple of things to talk about on this. Here's the first one. Remember, when we are looking at horizontal shifts, we had to factor out, if there was a number in front of x, we had to factor it out first. So think this, if I gave you something that looked like this, last unit, you were supposed to factor the -1 out of everything in the parentheses. That's what I'm talking about. The same is true for rationals. No, I deleted that page. There we go. The same is true for rationals. So the very, very, very first thing we need to do before we talk about anything is divide the negative out on the denominator. So it's going to look like this. We've got -2, and then we've got on bottom negative x plus 1, and then we can bring down our -3. Now look, you have 2 choices here, and I'm going to count both correct. So don't stress too much if you, as long as you understand one of these ways, it's fine. You could literally leave it like this, and you could just write out the transformations. If I did that, the transformations would be, in no particular order, an x-axis reflection, a vertical stretch by 2, a y-axis reflection, left 1, and down 3. And I would count that 100% correct, because that is correct. All that happens. You have another choice, though. You could, if you're really good mathy, that kind of thing, you could say, hey, I know that a negative divided by a negative is just a positive number. So don't those, after you've divided this negative out, you couldn't have done it here, but couldn't I say a negative divided by negative is a positive and just left it like this? And the answer is yes. So then your transformations would appear to be different. You would only have the vertical stretch by 2 left 1, and down 3. So the reason that both of these are correct answers, rationals are unique in that if you flip over the x-axis or if you flip rationals over the y-axis, they look the same. So if you flip over the x and the y-axis, both, you basically went back to what you started with. So what I mean, or just to show you really quick on the graph, here's my original rational. If I were to flip it over the y-axis, then it would look like this. If I flip it over the y-axis. If I were to flip it over, take the original red and flip it over the x-axis, I'm also going to get the blue. So by doing 2 reflections, you really went back to what you started with. Nothing changed. So a lot of people are more comfortable not trying to cancel out negatives, and they will write everything, and that is perfect. Some people notice both negatives or notice that these reflections cancel each other out. So they just don't find a need to write both of them. And so you could just have these 3. Okay. All right, guys, your Canvas assignment is on just this transformation stuff. And I am available at 3 today for help. I'm going to go type these answers in the transformations real quick so you can make sure you got them. And then I'll share that screen with you. All right, but make sure you do your Canvas today. And if you're having any questions or issues, please join me for tutoring at 3 o'clock today on this.